All right, well, here's an SAT problem, common SAT with geometry. Find the area of the total, find the total area of the whole triangle, triangle EDF. So the goal is to figure out the area of this whole triangle with this given information. They'll give you part of that segment right here as being 60, and A and B are midpoints of the two sides of the triangle. And that's all that's all the information that they give you. Excuse me. Now, to solve this, you have to know a few things. Number one, there is a theorem called the side splitter theorem, where when you take the midpoint of both sides of the triangle and you connect the when you connect the two dots and form a segment, this segment is half of um, the base and also parallel with the base. It always happens. It doesn't matter what kind of triangle you're using. It can look like something like this. It's quite amazing. You take half of that and half of this, I believe, and if you connect it, that gold line is half of the base, and it's also parallel. Okay, what else do we know about this? Well, because of that, we can now split the two triangles here, which will be, like, say, the top one and the bottom one, or the big one. And because the two lines are parallel, well, these two top angles, they're shared. That's this part right over here. But because the two lines are parallel, these two angles are corresponding. That means that these two angles are the same. Now we can use your AA theorem, angle, which will indicate that these two triangles are similar. Okay. Now, once you have similar triangles, you have to use this idea. Let's say that this is A and this is B. Well, if you have two similar triangles, the ratio of their sides is A to B. And if you square A to B, you'll get A squared, B squared, and these become the area ratio of the two triangles. If you happen to cube it, and if it's a three-dimensional picture, you'll get the volume ratios. Now, we're not going to use the third one, but we're just definitely going to use the second one right here. All right, well, we have no idea what this is right here. So let's split these two triangles up. This one is just an unknown area. This right here is x plus 60. So combined, we'll say this is 60 plus x. Okay. So what do we know? Well, we know that the two triangles are similar because of the parallel lines, because these 2 points, A and B, are midpoints. And it's midpoints, so this ratio will be 1 to 1. So that means the ratio of the sides will be 1 to 2. So 1 to 2 is the ratio of their sides, which is similar to saying things like A to B is 1 to 2. If you square it, it'll become 1 to 4. So what does that mean? If you take the area of the two triangles, they will be related. The small one will be 1, and the big one will be 4 times more. Well, that helps because now we can do this. 1 over 4 equals x over 60 plus x. Small triangle, big triangle, small triangle area, big triangle. All we have to do now is just use some common basic algebra, and we have that. So 60 equals 3x. Divide both sides by 3, and voila. X is equal to 20. So that's 20 right here. And now the total area is simply 60 plus 20, which is 80. And that's how you solve this problem.